In this example, we have y equals x cubed, and we need to find the equation of the graph after the following transformations. In part A, we've got a translation of 3, 0, followed by a horizontal stretch with scale factor 4, and in part B, we reverse the order of the same transformations. The purpose of this example is to show you the effect of reversing the order of the transformations when you apply them to a function. So let's apply the transformations in part A. First of all, we have a translation of 3, 0. Let's write down the effect that has. So, translating 3, 0 means replace x by x minus 3. Next, we'll apply the horizontal stretch of scale factor 4. Here, we need to divide x by 4. So applying the transformations in this order is relatively straightforward, and you get the answer you might expect. Let's now have a look what happens when we apply them in the reverse order. So first we have a horizontal stretch. Once again, we divide x by 4. Then we need to apply the translation of 3, 0. Now this is the point where people frequently make a mistake. We're going to replace x by x minus 3. However, we have to be careful because here the x is divided by the 4. So whatever we replace x by will also be divided by 4. So we get x minus 3 divided by 4. And if we split this fraction, we could write it as x over 4 minus 3/4. And so I think this result is a bit more unexpected than what we got in part A. And I often see students getting questions like part B wrong because they don't write down the working out when they've applied the transformations. They just write the transformations down and hope for the best. So whenever you're doing questions like this, particularly if the transformations are in the same direction, it's really important, write down the working out after each transformation. Right, here's one for you to have a go at then. It's a bit different to the one I've just given you because both transformations are in the y direction. For that reason, please resist the temptation once you've had a go at it to skip straight to the end and look at the solution. By doing that, there's a good chance that you might miss out on a key bit of understanding. Okay, pause the video and have a go at it then. Okay, welcome back. Here's my solution then. To start off with, we've got a stretch parallel to the y-axis, scale factor 5. So that's a vertical stretch. To apply that, we replace y by y divided by 5. Multiplying up by 5 gives us 5 times 2 to the x. This can't be simplified, so we'll now apply the translation. Here we'll replace y by y plus 1. So in part A, nothing out of the ordinary happens. Part B though is a little bit more tricky. We'll start by applying the translation. Nothing out of the ordinary happens in this part. We simply replace y by y plus 1. And then we can simplify. Then we'll apply the vertical stretch. So we're starting with y equals 2 to the x minus 1. And we're going to replace y by y divided by 5. Now the key point to remember in this bit is you must make sure that when you simplify this and you multiply up by the 5, you multiply everything on the right hand side by 5. So we get 5 times 2 to the x minus 5. It's a very common mistake for people to miss multiplying the 1 by the 5 as well.